The year 1941 arrived not with the gentle turning of a new decade, but with a shockwave of realization that the established global order was crumbling. Across the American continent, a nation built on consumer production watched the cold, terrifying efficiency of the Axis advance. The smokestacks of Detroit and Pittsburgh, which had recently churned out automobiles and refrigerators, now stood as silent industrial sentinels, waiting for the call to arms. When the call came, it demanded an unprecedented, almost unbelievable shift, the rapid conversion of a colossal peacetime economy into the arsenal of democracy. The pressure was relentless, churning, and often chaotic. Engineers, executives, and laborers were suddenly thrown together under the shadow of looming failure. They were tasked not just with increasing output, but with solving critical, existential crises that manifested on distant shores and deep oceans. Crises that threatened to strangle the American war effort before it could even begin to breathe. The story of American production in World War II is the story of 5 distinct industrial miracles. 5 critical solutions forged in fire and steel, each responding to an immediate, crippling threat to the Allied cause. The first, most immediate crisis materialized far offshore, in the frigid, oil-slicked expanse of the North Atlantic. From the moment war broke out, the German U-boat fleet, the gray wolves of the sea, systematically set about dismantling the lifeline, connecting American industry to Britain and the Soviet Union. Tankers erupted in flame, supply ships broke apart, and the desperate cry for materiel sank beneath the churning waves. By 1942, losses were catastrophic. Hundreds of thousands of tons of steel, food, and fuel lay scattered on the continental shelf. The sheer velocity of sinking ships far outpaced the traditional, slow methods of wartime shipbuilding. The solution was not a technological marvel in the way of a radar or a new engine, but an industrial revolution engineered by the unlikely figure of Henry J. Kaiser, a man who built dams and bridges, not ships. His vision was the Liberty Ship program. This was standardization applied on a scale never before imagined. Walk into one of Kaiser's massive, newly carved shipyards in Richmond, California, or along the shores of the Gulf, and the atmosphere was a dizzying, continuous assault on the senses. The air was thick with the sulfuric tang of welding flux and the metallic grit thrown up by endless streams of rivet guns. The ground vibrated constantly beneath the roar of cranes and the hiss of steam pipes. Traditional shipbuilding involved painstaking, slow craftsmanship, often taking months or even a year to complete a single vessel. The Liberty Ship model shattered this paradigm. Instead of building the ship piece by piece in the dry dock, immense sections, hull modules, engine room blocks, entire bow and stern sections were fabricated in workshops miles away, then hauled to the waterfront. These pieces, often weighing hundreds of tons, hung precariously from the hooks of gargantuan gantry cranes, their shadows sweeping across the docks as they were lowered into place. The primary innovation was moving away from riveting, which was slow and skilled work, and embracing continuous arc welding. The sight of the shipyards at night was spectacular and terrifying. Thousands of welding arcs flared simultaneously, casting sharp, brilliant white glares against the blackness, resembling a constant industrial thunderstorm. The result was an industrial miracle that defied military planners' most optimistic projections. The average time to construct a Liberty ship, a vessel 441 feet long, with a displacement of over 10,000 tons, plummeted from 240 days, down to a startling 42 days. One yard even managed the almost mythical feat of constructing and launching the SS Robert E. Peary in 4 days and 15 hours. A public relations stunt, perhaps, but one built upon the bedrock of relentless standardization and efficiency. These stark, functional vessels, designed for utility and rapid construction rather than grace, became the indispensable instrument of the Atlantic War. They sailed slowly, often in vast convoys, their angular hulls slicing through the gray chop. Many were lost, but for every one sunk, several more took its place, overwhelming the German U-boat fleet through sheer, tireless volume. The American production line had solved the Atlantic crisis by transforming the very definition of shipbuilding speed, guaranteeing the flow of materiel across the deadly ocean highways. As the convoy crisis was slowly being mitigated by volume, a second, equally critical deficiency became painfully apparent high above the European continent. Allied strategy rested heavily on the bombing campaign against the German industrial heartland. But the massive B-17 Flying Fortresses and B-24 Liberators, heavy with their payloads, were lumbering, vulnerable targets. They flew at altitudes of 25,000 feet, where the air was thin, cruelly cold, and unforgiving. The initial short-range American fighter escorts could protect the bombers only part-way, forcing the heavy craft to fly into the deep territory of the Reich alone. Exposed to the swarms of intercepting Luftwaffe fighters, the losses were sickening. Crews watched helplessly as their wingmen spiraled down, trailing black smoke. The cold blue sky swallowing their parachutes. Deep penetration air cover was the crisis. The bombers needed protection not just to the border, but all the way to Berlin and back. The answer arrived in the form of the North American P-51 Mustang, a machine that was initially a simple, sleek design. It struggled for recognition, but which became the most decisive air superiority fighter of the war. Its transformation hinged on a singular, critical integration, the adaptation of the British-designed Rolls-Royce Merlin engine. The initial Allison engine had provided adequate performance at lower altitudes. But when American engineers married the P-51's already elegant airframe to the powerful two-stage supercharged Merlin, the aircraft became a revelation. The sight of the P-51 was one of pure, functional grace. It was silver and streamlined, its wings exceptionally thin. These wings employed a revolutionary laminar flow design, minimizing drag. It allowed the Mustang to achieve extraordinary speeds and efficiency, giving it an unparalleled range. Pilots spoke of the distinct sound of the Merlin engine, not the muffled buzz of other American motors, but a deep, throaty growl, a promise of power and acceleration. Loaded with drop tanks beneath its wings, the P-51 could loiter for hours above the target zones deep within Germany, often flying 600 miles alongside the vibrating, slow-moving bombers before engaging the enemy. This extended reach completely changed the equation of the air war. The silver silhouettes of the Mustangs were the first things bomber crews looked for. Their presence a profound psychological relief against the terror of the Flak and the Messerschmitts. The young pilots in their Mustangs hunted the Luftwaffe relentlessly, forcing the once dominant German Air Force to retreat and conserve its meager resources. By 1944, the skies over Germany were contested and rapidly being claimed by the Allies. Largely due to this single, crucial piece of production, a mass-produced, high-performance aircraft that solved the long-range escort crisis and crippled the enemy's aerial defense. Below the whistling air battles and far from the churning ocean convoys, success on the ground depended on a quality often overlooked: rugged, tireless mobility. Armies needed to move fast, not just on paved roads, but across Libyan sands, through Italian mud, over jungle tracks in the Pacific, and across the frozen tundra of the Ardennes. The sheer variety of terrain and mission requirements led to a third critical crisis: the need for a ubiquitous, highly adaptable utility vehicle that could survive abuse and be repaired anywhere, quickly. Tanks were specialized, trucks were too large. What was needed was a small, versatile workhorse. The solution that became perhaps the most enduring and beloved symbol of American wartime ingenuity was the quarter-ton truck, the vehicle known simply and universally as the Jeep. The design competition was fierce and rapid, demanding a vehicle that was lightweight, powerful, four-wheel drive, and utterly dependable. The resulting design, primarily developed by Bantam and refined by Willys Overland and Ford, was a masterpiece of functional geometry. It was boxy, stark, and utterly devoid of comfort, yet it possessed a resilience that bordered on the miraculous. The Jeep's sensory reality was defined by its mechanical noise and its bouncy gait. It rattled over every stone and rut, the sound of its four-cylinder engine a persistent, recognizable thrum, mingled with the smell of hot oil and leaking gasoline. Its open frame meant that the driver and passengers were constantly exposed to the elements. Dust coating their teeth in the desert, rain soaking them instantly in the jungle, and frost biting through layers of wool in winter campaigns. But the Jeep transcended its simple origins. It towed artillery pieces across impossible slopes, served as an ambulance, mounted machine guns for reconnaissance. It acted as a radio communication platform and transported generals and privates alike. It was small enough to be hoisted onto gliders or slung beneath aircraft. Troops developed an immediate, deep affection for the vehicle, recognizing its reliability in the most hostile circumstances. Crucially, its production was simple and rapid. Ford and Willys scaled up production to staggering numbers, ensuring that wherever American or Allied troops were fighting, there were Jeeps, hundreds of thousands of them, providing the foundational mobility that transformed scattered infantry into a truly mechanized, agile fighting force, capable of tackling any terrain crisis the planet could present. As the war progressed and American production geared up for the ultimate goal, the invasion of the hostile European and Pacific shores, a fourth and perhaps most terrifying crisis loomed: how to get hundreds of thousands of troops, their vehicles, and supplies from the rolling decks of ships directly onto fortified beaches under murderous enemy fire. Traditional ship-to-shore transfer was slow, messy, and resulted in high casualties far out in the surf. Massive amphibious operations like D-Day were impossible without a radical, high-volume solution to this complex logistical and tactical challenge. The solution came from the bayous of Louisiana, from the mind of an unlikely, impassioned boat builder named Andrew Jackson Higgins. Higgins was obsessed with shallow draft vessels, initially designed for logging and oil exploration in the swampy American South. When the military approached him with the invasion problem, he refined his existing designs into the legendary landing craft, vehicle, personnel, the ubiquitous Higgins boat. This craft was not a vessel of beauty or comfort. It was a rough, functional instrument of war. Its primary construction often involved marine plywood and steel plating, built to be robust enough to take a beating on a sandbar, but light enough to skim quickly over shallow water. Stepping onto a Higgins boat for an invasion was a profound sensory experience, dominated by tension. The air was thick with the smell of diesel fumes, mixed with the sharp, cold tang of salt spray. Troops were packed shoulder to shoulder, their gear clanking softly, staring at the high, stark walls of the boat. The noise of the engine was deafening, a persistent vibration beneath their boots. As the craft pitched and rolled, driving toward the foaming surf line. The genius of the Higgins boat lay in its stark frontal ramp. As the boat neared the beach, the terrible moment arrived. The ramp slammed down with a resounding metallic clang, instantly transforming the enclosed protective vessel into a gaping gateway to hell. This simple, elegant design allowed fully equipped troops to rush forward directly onto the dry sand, rather than floundering in deep water, often carrying their heavy gear while under intense machine gun fire. Eisenhower himself called Higgins the man who won the war for us. His factories in New Orleans operated around the clock, constructing these indispensable landing craft at breakneck speeds. The sheer volume was staggering. Over 20,000 Higgins boats and variants were produced. They were the key to translating overwhelming industrial power into projected military force, solving the beach landing crisis by providing the critical vehicle necessary for all major amphibious assaults, from Guadalcanal to Omaha Beach. Finally, beneath the steel hulls, the roaring engines, and the grinding gears of the mechanized army, a fifth insidious crisis threatened: the entire foundation of the war machine. Unlike the immediate, visible threats of U-boats or enemy fighters, this threat was rooted in geology and geopolitics. The loss of access to crucial natural resources. Specifically, the Japanese conquest of Southeast Asia severed over 90% of the world's supply of natural rubber. Rubber was not a luxury, it was the essential, critical component of everything that moved. Tires, tank treads, gaskets, seals, hoses, communications equipment. The entire flow of material depended on rubber. Without it, the vast engine of American industry would grind to a halt. The crisis demanded immediate, massive substitution. The response was a breathtaking pivot toward volatile industrial chemistry, mastering the art of synthetic rubber production. This was perhaps the least glamorous of the 5 industrial solutions, often hidden away in sprawling, anonymous complexes, yet it was arguably the most vital for long-term victory. The government launched a crash program, investing hundreds of millions of dollars to transform petroleum refining capabilities into chemical plants, dedicated to synthesizing butadiene and styrene, the key precursors to the most promising synthetic rubber compound. GRS, Government Rubber Styrene. The atmosphere in these new synthetic plants was one of intense pressurized heat and the pervasive, heavy smell of industrial solvents and sulfur compounds. Massive, steaming vats and towers dominated the skyline, complex piping carrying highly volatile chemicals through elaborate distillation and polymerization processes. This was a battle fought by chemists and refinery workers, not soldiers, yet the stakes were equally high. The initial challenge was enormous. Early synthetic rubber was inferior, difficult to process, and prone to cracking. But through sheer scientific dedication and industrial scale, the quality improved rapidly. American industry, particularly companies like Standard Oil and DuPont, scaled their facilities with brutal efficiency. The output was legendary. Before Pearl Harbor, the U.S. produced virtually no synthetic rubber. By 1944, American factories were churning out nearly 820,000 long tons annually, more rubber than the entire world had consumed in any year prior to the conflict. This enormous volume completely secured the base of the war economy. The Jeeps continued to roll on their robust tires. The B-29s flew with their intricate hydraulic seals. The tanks maintained their treads. Synthetic rubber solved the resource crisis, guaranteeing that the small, critical components necessary for motion and function remained available, ensuring the relentless flow of material that ultimately sustained the grinding victory. Taken together, these 5 acts of industrial mobilization, the mass-produced Liberty ship, the high-performance P-51 Mustang, the ubiquitous Jeep, the essential Higgins boat, and the chemically forged synthetic rubber did more than just equip an army. They fundamentally restructured the American industrial landscape. Each solution was a direct answer to a crisis that threatened to paralyze the war effort. The speed, scale, and innovative spirit with which these solutions were designed, manufactured, and deployed stand as the definitive testimony to the power of the arsenal of democracy. It was the culmination of countless hours of welding glare, the throaty roar of engines being tested, the smell of fresh paint mixed with sea salt, and the tireless, anonymous work done deep within the steaming heart of American industrial plants. These products of relentless production were the tools that transformed a defensive struggle into an overwhelming global offensive.